Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to talk about a problem that you'll likely see if you're doing especially well on the ASVAB. When I was taking the ASVAB, I remember seeing these problems almost verbatim, and I ended up scoring in category 1. That is, I scored somewhere between 93 and 99. So let's go ahead and talk about this problem. If for some reason you don't understand this problem, you may want to go ahead and check out my other video called Mastering Distance equals Rate times Time. This problem is much more advanced than anything in that video, and as I said, if you can do this problem on your own without my help, you're probably going to score very high on the AFQT. So that said, let me read the problem. Go ahead and pause it and try to work it out on your own, and then I'll show you how I solve the problem. The question is, a boat covers 16 miles in 2 hours while traveling downstream. To go the same distance upstream, it takes the boat 4 hours. What is the speed of the boat in still water? So by now, especially if you watched my older videos, you know we're dealing with this formula. Distance equals rate times time. Okay? That said, in this problem, we don't know what the rate is. And we also have to deal with a new variable, which I'm going to represent as C for the current. Okay? And these two are related. That is to say, when you're traveling downstream, the current's increasing your rate, and when you're traveling upstream, the current is decreasing your rate of speed. Okay? So what I like to do when I'm working with two different situations, namely upstream and downstream, is to create a little chart so I can keep things in order. The first thing I'm going to put in my chart is distance. The second thing I'm going to put is rate. And the third thing I'm going to put is time. Now, in this case, we know that the boat covered 16 miles upstream and 16 miles downstream. So we'll go ahead and fill that in accordingly. We know to go downstream, it took the boat 2 hours, and to go upstream, it took the boat 4 hours. Okay? Now, we don't know what the rate was. It's not given. But we do know, as I just mentioned, when you're traveling downstream, the current actually speeds your rate up. So I'm going to represent the rate in this case as rate plus current. Again, that current's speeding you up. And for this case, when we're going against the stream, it's slowing us down. So I'm going to represent this as rate minus current, because the current is taking speed away from you. So now that we have everything set up, all we really need to do is find the rate and the speed of the current. So let's go ahead and think about how we're going to do that. I know this is how the formula is traditionally written, but to make things easier, I'm actually going to write it as this: rate times time equals distance. It's the same formula. I just took this and moved it over there. So again, we know our rate. Our rate is R plus C for this one. We know our time is 2 hours for this one, and we know our distance is 16. Okay. For this one, we know our rate is R minus C. We know our our time is 4 hours, and we know our distance is 16. Okay. Before I go any further, I just want to distribute this 2 to the R and the C, and distribute this 4 to the R and the C. So I'm basically going to distribute it there, and there, and there, and there. So 2 times R is 2R, 2 times C is 2C, equals 16, of course. 4 times R is 4R. 4 times negative c is negative 4c equals 16, of course. Now I'm going to simplify these equations a little bit further. That is, I'm going to divide everything in the top equation by a common factor of 2. And I'm going to divide everything in the second equation by a common factor of 4. So everything basically is going to be divided by 2. Everything is going to be divided by 4. 2r divided by 2 is just r. 2c divided by 2 is just c. 16 divided by 2 is 8. 4r divided by 4 is 4. Negative 4c divided by 4. Whoops, I made a mistake there. 4r divided by 4 is just r. Negative 4c divided by 4 is just negative c. 16 divided by 4 is 4. Okay? So let me rewrite that so it's clear over here. R plus c equals 8. R minus c equals 4. Now we have a system of equations that we can solve to get our rate as well as the speed of the current. And if you recall, what you do is you add the equations together to get rid of one of them, and then once you find the other one, you plug it in to get the other variable. In this case, I can see right away if I add positive c to negative c, that's going to go away. So what I'm going to do is I'm going to leave the top one the same, r plus c equals 8. And I'm going to add this first equation to this second equation. So that's going to give me r plus r, which is 2r. C minus c is 0. And 8 plus 4, which is going to be 12. So as you can see, by adding the top equation to the second equation, I got rid of the variable current. Now I can actually solve for the rate. So let's go ahead and just focus on this second equation. We have 2r equals 12. We can divide both sides by 2. This crosses out. We're left with r equals 12 divided by 2, which is 6. So we know the rate at which the boat is traveling in still water is 6 miles per hour. Okay? And if I wanted to find the current, I would take this r, plug it right here for r, and find the current. So let's take a look. Again, r is 6, so we're going to go 6 plus c equals 8. Subtract 6 from both sides. 6 minus 6 is 0. We're left with c equals 8 minus 6, which is just 2. So now we know the rate is 6 miles per hour and the current is 2 miles per hour. So let's go ahead and think about it. Again, we're dealing with distance equals rate times time. In this case, our rate is, we're going downstream in this case, so our speed is going to be helped by the current. We know the rate is 6, the current's 2, so this is 8. Again, distance equals rate times time. 8 times 2 equals 16, so this checks out. In this case, we know the rate is 6, the current speed is 2. 6 minus 2 is 4. 4 times 4 is 16, so it checks out. So again, this is a problem you're going to see if you're doing really well in the ASVAB. If you struggled with it, don't worry about it. Chances are very few people will actually see stuff like this. But feel free to leave some feedback in the comments below. If you want to see more advanced problems like this, just let me know. But on that note, I'm going to go ahead and cut you loose. こんにちは。